Everyone, my name is Jan, and as Matthias already said, I work as cybersecurity analyst at our SOC now for almost 3 years. Before changing my work-related focus and moving to SOTs, I was primarily working with different data center solutions such as VMware, SCCM, Hyper-V, and also been deploying Exchange environments. In the last years, my focus shifted towards cybersecurity area, where I'm involved, at least for the part pertaining to Microsoft technologies, when we are doing security hardening projects for our customers.
Welcome, my name is Jakob Premrn. I'm a cybersecurity analyst at NIL. I worked there for 1.5 years. I'm an expert in network and infrastructure security. During the work, my responsibilities are taking care of cybersecurity incidents, taking care of infrastructure, and giving advices about improving cybersecurity postures in organizations.
Before moving to the main topic of today's webinar, let's first take a brief look at the agenda. Initially, we will try to give you some context about cloud-native SIEM systems and how Azure Sentinel fits into this area. Afterwards, we will cover 4 main topics that also represent the 4 main functionalities or pillars. Each modern SIEM system should be capable providing them. So no matter where the SIEM is running, be it in your on-premise data center or in the cloud, such as, let's say, Microsoft Azure Public Cloud. These functionalities are the first one. Each SIEM solution must be capable of collecting events from different data sources. This is a requirement, but of course is far from enough to have visibility into the happenings inside your IT environment. So to put it in one word, we could name this SIEM functionality capability as collect. Next comes the functionality to detect a suspicious event. Usually this happens automatically when a detection rule is triggered, and this produces an alarm, or in the Azure Sentinel speak, this detection rule produces an incident. Here we also have an additional method how to detect not normal happenings in the environment. The method is named hunting, or to be more precise, threat hunting. Threat hunting is usually a manual activity to search for unusual events and then finding patterns in the data, and as a last step, to also create detection rules based on these findings. The third pillar is that each triggered alarm or incident must be, of course, also researched or investigated by a security analyst. The investigator must decide if it goes for a false positive or a true positive incident. This phase of the investigation, the first part of the investigation, is named triage, and SIEM system must provide tools to help the analyst to do the triage, and also afterwards, when this first step is completed, to continue with the investigation if it was decided that it goes for a true positive incident. And finally, if you want to keep your information system, your IT environment secure, you have to act. You have to do something to stop an ongoing cyber attack. So in the last few years, SIEM systems became capable to also respond to incidents, which means that SIEMs are evolving and are becoming also SOAR tools. But let's first check what are today's challenges in the IT field, and especially in cybersecurity area. It is quite obvious that digitalization won't stop, but on the contrary, it is in fact assimilating areas that were just only a few years ago existing only in the so-called analog world. But also, in addition to the space, the digital space is increasing, it is also creating brand new digital-only fields. And by some estimates, each year, at least 40% more data is being generated compared to the previous one. Also, one of the challenges is that employees are accessing their work-related data from a very diverse set of devices, such as laptops, smartphones, tablets, smartwatches, and each year some new gadgets. Some new gadget is sold on the market, and each such device that accesses data pertaining to the organization should send back at least some events that can be then analyzed by the IT department, or if the organization has established by the Security Operations Center. So all these devices, of course, raise the number of events that a single person, a single analyst must deal with. And then we also have a large skill shortage in this area. So it's not that easy to find skilled candidates to work as security analysts. So this means that alert fatigue can happen, and of course this is quite often experienced by security analysts working as in this area. Again, then we have the other side, let's say so, dark side of the IT. Here I have in mind cyber attackers, or also organized groups that are known as advanced persistent threat groups, which try to exploit all these holes in cybersecurity and gain unlawful access to your IT environment. Such attackers usually try to gain access to the systems that provide crucial services to keep your business running. And the foothold, as it is set in the IT environment, is obtained without you even knowing it, or at least it is released that someone gain access to the environment only after a few months or even years. So let's see how Microsoft, with the help of Azure Sentinel, tries to address all these challenges. First, Azure Sentinel is a SIEM solution, and at the same time, it's also a security orchestration, automation, and response solution, or SOAR solution. Azure Sentinel was built from ground up to run only in Azure Cloud. It could be said that Sentinel is a SIEM and SOAR as a service solution. Most likely, you already know the advantages of running solutions in public cloud, but let me just quickly recap the most obvious ones. High scalability of public cloud, such as Azure Cloud. So because Sentinel is a service and not just a virtual machine running in Azure, there is a special SLA, which states that the service will be accessible almost for 100% of the time, 99.99. Then we don't have any expenses related to maintenance of Azure Sentinel as compared to the costs when we are running an on-premise SIEM solution. And we also don't have any initial costs pertaining to the hardware that we must provide when we are having a classic SIEM, and also if we are running a SOAR solution. Okay, going back to the benefits and features specific to Azure Sentinel. Azure Sentinel can be very simply integrated with the so-called natively running security solutions in Azure Cloud, such as Azure ATP. Additionally, there exists also many different connectors, as Microsoft names these integration services, with services running in other public cloud providers, such as, let's say, Amazon Web Services. And then it can also integrate with Salesforce, Dropbox, and out of box, there also exist some additional third-party connectors. Integration with the on-premise solutions is done using a similar method as when we are running a classic on-premise SIEM, but more on this will tell you Jakob in the following chapter about visibility. Then, when we are having a service such as a SIEM natively running in a large public cloud data center, we also can have machine learning algorithms, and Microsoft implemented this, that are trained on a large amount of signals which are produced inside a cloud provider. So machine learning algorithms are built in Azure Sentinel, and these algorithms provide higher confidence for some incidents when they are triggered. Then Azure Sentinel also has a feature, or it's using a feature named playbooks. And by playbooks, we can simplify repetitive tasks that would otherwise consume a lot of time for the analysts. For example, let's say that we have a public IP address that appeared in an incident, and we would like to get some additional information if this IP address was maybe already active in some other malicious activities. Last but not least, I think it is also important to mention that Microsoft each year invests quite large sums of money in cybersecurity field, and Microsoft has committed to raise the security, let's say, to a higher level. And this can be also seen in the high number of security experts that are employed by Microsoft. I think around 3,500 security experts work for Microsoft. All this considered, Sentinel will definitely be a crucial part to achieve the objective of, let's say, raising the cybersecurity to a better level. So now I'm giving the work to Jakob.
Thank you, Jan. So before we can start using Azure Sentinel, we have to somehow bring data to it. To bring data to Azure Sentinel, we have to use connectors as Microsoft calls them. For example, in QRadar, they are called DSMs. In reality, connector is a protocol, for example, syslog or CEF, or an API, plus an event parser, which is responsible for normalizing events accordingly so that they can be used later in a variety of detection rules. But by default, in Azure Sentinel, we have 60 connectors available, which can be separated into 3 groups. First group of connectors are service-to-service connectors, which are used by applications which reside in Azure by default. Second group of connectors are connectors that communicate with solutions via an API. For example, it's an F5 firewall. The last group of connectors are connectors which need a specially dedicated agent for communication with Azure Sentinel. It is also important to notice that all connectors come with analytic rules templates integrated in Azure Sentinel, and these templates can be used for later creation of analytic rules. This photo shows a better presentation how data connectors in Azure Sentinel work. The left side of the picture presents data connectors which communicate with solutions native to Azure. Those solutions are service-to-service integrations, and these connectors are usually the richest. By this, I mean that communication is bidirectional. For example, we can block a specific user in Azure AD if that is necessary. The right side of the photo shows third-party connectors and also solutions that reside on-premise. To integrate such solutions into Azure Sentinel, we have to use a collector proxy. This is a specially dedicated proxy server, or we have to use a dedicated agent which is installed on each endpoint. Now let's take a look how we can integrate logs from Palo Alto Firewall into Azure Sentinel. First, we have to install a Microsoft monitoring agent on a Linux virtual machine, which will serve as a collector proxy. Then we have to configure Palo Alto Firewall so that it sends logs to this proxy. Logs have to be sent in CEF format. Next, we have to wait approximately 20 minutes, maybe a bit less, for the logs to show up in Azure Sentinel. And the last step is just to confirm that the events are being forwarded to Azure Monitor and that they are visible in Azure Sentinel. As you can see on the right side, all instructions of configuration are written in Azure Sentinel. And just to mention configuration of Palo Alto Firewall is one of the hardest. Now let's take a look how we can integrate logs from Windows endpoints. This integration is also done with help of Microsoft Monitoring Agent, which is installed on endpoints with Windows operating system. We can also use Log Analytics Gateway or SCON Server if we have it installed in our environment. Next, we only have to choose the amount of data that will be forwarded to Azure Sentinel, and voila, we are there. Now, in the next presentation, I'm going to show you how simple it really is to make an integration of a cloud native solution from Azure to Azure Sentinel. Let's go to data connectors and let's search for Cloud App Security. Let's click Open Connector page at the right bottom. And now the only two configuration options are to select if we want to forward alerts and also cloud discovery logs. On the left side of the screen, we can see a graph. At the moment it's empty, but later it will be full because it shows how much data was already ingested in Azure Sentinel. In the next steps, we just have to verify by built-in queries that the data is being received to Azure Sentinel. At the top, we can see our KQL query, and at the bottom, we see the data, and we can confirm that the data was ingested to Azure Sentinel and connector work. Let's go back to Azure Sentinel. On the left side, we can already see that the graph is not empty anymore, but it shows that data is coming to Azure Sentinel. And at the bottom, we also see that, the connector has analytic rule templates, which can be used for creation of analytic rules. I'm giving word back to Jan.
Okay, next building block that is crucial for a functioning SIEM system is the capability to detect anomalies in the environment, or to phrase it in a more general way, the capability to detect security incidents. In Azure Sentinel, we have a section dedicated only for this feature. The section is named Analytics. And out of box, that is when Azure Sentinel is activated in the tenant, we get 158 analytics rule templates that can be later used to create detection rules. The templates and of course later on detection rules use Custo query language to obtain specific events which are stored in Azure Monitor subsystem. Azure Monitor is a service running in Azure and is used to collect different kinds of events. So Azure Sentinel is built on top of Azure Monitor and also some additional services already existing in Azure Cloud. Each rule template is classified by MITRE attack tactic, and we also have 4 groups. Each group represents a type of detection rules, and the first group is named scheduled rules. These are the rules that are periodically activated, let's say every 10 minutes or every hour. Then we have Microsoft security rules, which are very simple rules as they activate each time when an event comes to Azure Sentinel from one of the native Azure security solutions, let's say Azure ATP, or maybe from Azure Active Directory Identity Protection. Then also Microsoft Defender ATP would trigger such rule, and there are some others also. Then we have also entity behavior analytics rules. These are related to user and ATT behavior analytics, or UEBA. Alarms that are triggered by these rules are connected or come from cloud discovery functionality, which is a feature that is part of Microsoft Cloud App Security solution. And last but not least, we have a category named Fusion, which currently contains only one rule. The rule is kind of a black box, as at the moment it is possible only to turn it off or on, but in the background it uses machine learning algorithms. And speaking of which, as already said at the beginning of the presentation, having Sentinel running as a service in Azure gives it quite simple access to a vast quantity of signals that are produced by different solutions. So security solutions such as Azure Security Center, then Office 365 ATP, Azure AD Identity Protection, Microsoft Defender ATP, and some others. Each this solution is connected with each other via a common bus named Intelligent Security Graph, and the mentioned the detection rule Fusion, with the help of machine learning algorithms in the background, can, let's say, fuse signals from seemingly disconnected sources. Then it normalizes them and tries to find patterns that could indicate that something malicious is going on. Currently, only one rule in Azure Sentinel exists that uses this fusion subsystem. The rule is named Advanced Multi-Stage Attack Detection, but in the near future, it will be possible to use your in-house developed machine learning algorithms, and Microsoft has named this initiative as build or bring your own machine learning into Azure Cloud. Just one more thing. The built-in analytics rule templates, and then also the detection rules that we create from them, we can look upon them as a correlation table which connects attacks. So basically, this is what we are trying to detect. Then different tactics from MITRE ATT&CK matrix, and also the most important part, the data sources, which are needed for a functioning detection rule, of course. But the basic premise is that having a large amount of detection templates out of box gives you a good starting position to create and then also enhance these rules and create maybe rules that fits better your specific situation or the environment that you are trying to monitor. So in the short video clip, we will take a look at how simple it is to create a new detection rule based on a template. So we will try to detect a port scan by using Palo Alto firewall as data source. But first, when we are creating a new rule, we have to find the right template. We have to filter for Palo Alto in the data source field. And the new rule that we will create from the template named possible internal to external port scanning. So this is the rule that falls into the scheduled rule group and uses KQL query, which can also be freely customized. And we will set the time frame to 2 days, and also we will change the working set, which will include also the events from the last 2 days. Basically, this last attribute defines the data on which the KQL query runs. Then what is left is to click just next 2 times. Just before creating the rules, we can also attach a playbook. So each detection rule can have one or many playbooks that are triggered when the rule is run. But okay, fortunately in our case, we don't have any playbooks created. So when the rule is finally created, all what is left is to check if the rule already generated any incidents. And so as you can see, incidents are accessible from the incidents section, and we already have 3 incidents that were generated by this particular rule. So yeah, I'm giving the word back to Jakob.
Thank you, Jan. Statistics show that the average time for a threat actor to be detected in an environment is 200 days. Can you imagine that one person is in your environment for 200 days? He collects data, gathers information about you, but you don't have any idea about him. What about even better threat actors who use even stealthier and harder detectable methods for lateral movement. To detect such threat actors, we have to take things into our hand and start to be proactive. Proactive search for adversaries is called hunting. Using hunting, we search for abnormal or very rare things that happen in our environment. For example, we can search for protocols that are the least used or which program runs the least amount of times, and so on. Microsoft offers a very good platform for hunting in Azure Sentinel. Also, cybersecurity experts from Microsoft developed around 100 scripts which we can use for hunting. Those scripts use a KQL language, which is very similar to CQL. The only difference is that KQL language is faster and more powerful. Using KQL language, we can analyze million lines of code in a matter of seconds. When we find something interesting using a hunting query, we can save it for a later investigation as a bookmark. Hunting queries do not run so often as analytic rules, but they run once a week, once a month, because otherwise we would get too much data, which we would not be able to analyze and also to understand. When we develop new hunting queries, we have to test them, see if the query works, and also if it gives us data that we want. Because hunting queries do not run so often, when we would develop a new query, we would have to wait for a few weeks before we know if the query works correctly or not. For a workaround around this, Microsoft offers us a live stream. Live stream allows us to test newly created queries on a live data, and it alerts us when there is a hit. In the next demonstration, we are going to see how we can search for new admin activities in our environment. So let's go under Hunting tab on the left side, and now let's search for the template for new administrative activities. Let's run the query with the button on the right side, and we will see that we got one result. Let's click View Results to view the result. On the top, we can see our KQL query, and below there is a result. We can expand the result to get more information, and we can also save it as a bookmark for a later investigation. To save a bookmark, we have to give it a name and create it. Bookmarks are accessible in Azure Sentinel under Hunting tab. So let's go back to Azure Sentinel under Hunting and Bookmark. Here we can see our newly created bookmark. We can investigate it by clicking on Investigate button. Now we are taken to an investigative graph from which we can investigate the incident. How to interpret this graph, Jan will explain you a bit later. The last thing to do is to check live stream. Live stream allows us to test newly created queries. So let's create a new live stream by clicking New Live Stream on the top of the page. And now let's give it a name. And we also have to write a KQL query that we want to test. Now we have to save the live stream, and also at the top we can see that we can immediately create an analytic rule if we know that the query works fine. We can test the live stream from here and wait for the result, or go back into Azure Sentinel and run it from here, in which case it will run in background and we will be alerted on a new hit.
Okay, thank you, Jakob. So going back to our agenda, and we are in the third stage. So the third building block comprises a modern SIEM system is the ability to investigate security incidents. This feature in Azure Sentinel can be found under the section named Incidents. And let's say that this is the feature that is most frequently used by a SOC analyst, as it represents the starting point to any kind of incident investigation. So incident functionality is also by far the most integrated feature with all the other capabilities that are provided by Azure Sentinel. So we have our Sentinel integrated with a ticketing system. When an incident is triggered, automatically a ticket will be opened in Jira or ServiceNow, or depends on the platform that we are using. We've already mentioned playbooks a few times today, and during incident investigation, they can help the analyst enrich the entities that are part of the incident. So, for example, we can check when was the last time the user changed their password. So playbooks are the functionality that expands Azure Sentinel into the area pertaining until now exclusively to SOAR systems. But let me give you a more complex example of a playbook which interacts with two different systems. We have an email gateway that detected an attachment which contains an executable file, but this file wasn't blocked by the antivirus solution that runs on the mail gateway. So Azure Sentinel, with the help of a playbook, can obtain this attachment from the gateway, send it to a sandbox solution, which then automatically starts a dynamic analysis of the executable. And at the end, the result of such analysis is usually a report. This report is again obtained by the playbook and attached as a separate entity to the incident, which is then investigated by the SOC analyst. Okay, maybe I've drifted a little bit off topic, because more on the automation and orchestration part will tell you Jakob in the next chapter. But I thought that this is one of the functionalities that is deeply related with the incident investigation, and that's why I took some additional time. So anyhow, let's take a look at how visualization of an incident looks like. So once we have an incident and we clicked on the button investigate, we are taken to the visualization board, where all the entities and their relations that are part of a particular incident are dynamically constructed as a relationship graph. And then if I move my mouse over the entity that represents a user, we can get additional events related to this particular user, like event named user account failed logons, or user account remote interactive logon. And all these events are obtained from different data sources that send logs to Azure Sentinel. So user account failed logons is, I think, obtained from domain controller, which monitors all the authentication events that are coming from different Windows endpoints. So all this information, which is accessible directly from the entity, gives to the analyst much needed additional context when he's trying to understand what is really going on in this particular incident. So then if I click on the related alerts, it will show me the incidents where this user was also included in. So if we take a more detailed look into the incident remote code execution attempt, it will expand into 3 new entities, and these entities are 3 computers which are related to this user. In all these incidents, the common denominator is the user that we are investigating. And then going back to the other related incident named unfamiliar sign-in properties, clicking on it will show us a public IP address from which the user authenticated to Azure Active Directory. So long story short, visualization of the incident gives the analyst insight into the happenings around the initial time of the incident that we started the investigation with. Just one more thing, on the right side, we have a button named timeline, and clicking on it will show us all the incidents arranged in time succession. Again, this helps to understand which event or which incident led then to the potentially malicious activity that we are investigating. I think that I have to emphasize this when we are clicking around this entity relationship graph. When I was expanding the entities or was checking the additional events related to the user, Azure Sentinel in the background was executing KQL queries and practically without any delay also displaying the results. Okay, so giving the stage back to Jakob.
Thank you, Jan. Cybersecurity is not a one-time job, but it is a process. And in this process, cybersecurity analysts have to analyze quite a large amount of cybersecurity incidents. Those cybersecurity incidents can sometimes be repetitive, and cybersecurity analysts already know the answer for a specific incident. Because engineers by nature are a bit lazy and we want to automate and improve things, Microsoft helps us with automatization and orchestration tool called playbooks. Playbooks are built on top of logic apps, which are a module in Azure and allow automatization of any work processes. For example, we can create an automatic script that pays a bill under a specific amount of under a specific value, but if a bill is higher than a specific amount of value, it will be forwarded to the correct person in our organization. Of course, we can also create automatic scripts for cybersecurity things. For example, we can open a ticket in our ticketing system whenever a specific incident is created in Azure Sentinel. Those automated scripts can be ran automatic or manually. On the next slide, let's take a look how such script looks like. All automatization scripts are written in Logic App Designer. Every script also has a trigger, which triggers a workflow and takes the script to the response. Workflow is basically connection of different blocks, which are put together like Lego cubes, and each of those blocks present an integration with a specific application. Those applications are not necessary from Microsoft, but they can also be third party. For example, Jira, Snow, and so on. In the following demonstration, I'm going to show you an example of an automatic script. Now we are in Logic App Designer, and you can see that there are quite some templates which we can use for creation of automatic scripts and of automatization. automation of our processes, but we will use a blank template. We will create a script in which we alert our cybersecurity team when a newly created incident is created in Azure Sentinel. So the trigger will be an incident creation rule from Azure Sentinel. In the next step, we just have to alert our security team. To do that, we have decided to use an email. We will use the Microsoft solution Office 365 Outlook. Now we have to search for module sent email. We can see that there are a lot of modules we can use, and we can create quite a lot and a different number of automatization scripts. Now we have to fill the email data, and we will also put a dynamic content, which will be the URL to newly created incident in Azure Sentinel. Next step is to save the script and to test it. To test the script, let's go one step back and run the trigger manually from here. Now, in a few moments, we should receive an email. The email came. Let's check the email to see if it's correct. We can see that all data is in the email except the URL. The reason behind that is that the script was triggered manually and not automatically, and because of that, the URL didn't come. But if the automatization script was triggered automatically, we would also see a URL here, which would take us to our newly created incident in Azure Sentinel.
Okay, thank you, Jakob. So until now, we try to show you some of the functionalities that are offered by Azure Sentinel. But remember that this was all very high level, and there are many additional topics that we weren't able to address as Sentinel, as all the SIEM solutions and also SOAR solutions is also very complex. But nonetheless, let's take a look at how Microsoft sees the evolution, if I may say so, of a basic SOC into a more advanced one. The main role is assigned to the SOC analyst, and in the most basic version of Security Operations Center, the analyst's role is to respond to alarms that are triggered by SIEM system. So on-prem SIEM receives raw log events from different solutions that are deployed in the environment, and based on the configured rules, different alarms are triggered. The role of SOC analyst, so in other words, SOC analyst represents also the Security Operations Center, the whole SOC, can be outsourced to an external party or to a managed detection response or MDR provider, such as NIL. And we offer our MDR service named NIL SOC. Then next evolution step in security operations centers would be using advanced security solutions which have some threat intelligence capabilities already built in and can trigger an alarm if malicious activity is detected. Such solutions would be, let's say, next generation firewalls, endpoint detection response solutions, data loss prevention systems, some intrusion detection systems, and similar. All these systems can forward to SIEM just the alarm without all the raw data events. Here, I think it is worth mentioning the broad portfolio of Microsoft security solutions named Microsoft Defender XDR, and solutions under this umbrella communicate with each other using the already mentioned intelligent security graph, which provides them with the latest threat intelligence information. course, all these added solutions give SOC analysts additional responsibilities, and to get a more clear picture what is going on in the environment, the analyst can reach out to the third-party threat intelligence providers and enrich the data with the missing information that is not obtained from different solutions that are present and deployed in the environment. So at this stage of the Security Operations Center, let's say that we are approaching to a critical point when it becomes very difficult to manage all these disparate and complex solutions, and a need arises to have, again, a brand new tool which will allow us to manage in one central location all these systems. This tool is SOAR, which can interact with firewalls, Active Directory, different ADR solutions, and so on. But then putting everything to even higher level, which usually means that we need to simplify things. And a need arises to merge some solutions. So Azure Sentinel was, let's say, invented, and it covers both roles. So it is a SIEM system and also a SOAR system, which is then topped with machine learning algorithms that are provided by Azure Cloud. So this would be all from my part and Jakob. If you have any questions, as Matthias already said at the beginning, you can write them in the QA chat window, and we will try to answer them. So Jakob, is there anything?
Yeah, we have two questions at the moment. The first question from Dragan is a question regarding KQL and detection rules. Are there any template libraries available where we could find additional useful or pre-built templates that we can import? Jan, are you going to answer?
Yeah, I will try to answer this. Yeah, so of course, as we were discussing during the presentation, a lot of detection rules are already built in Azure Sentinel, but Microsoft is also trying to build a large community centered around Sentinel, and there are some good sources of information related to detection rules, hunting rules, and so on. And definitely a good starting point would be using GitHub repository. There are also some third-party teams. The one that we here at NIL use for getting some ideas is a team named Blue Teams Labs on GitHub. And of course, also it is nice to check the tech community forum, specifically dedicated to Azure Sentinel. This is, of course, a good starting point if you have any problems that you need to troubleshoot. First, of course, check the tech community forum before opening a support ticket. And yeah, of course, Twitter, as it is popular in cybersecurity field. Twitter, especially, again, Swift on Security has some good content that can be used also when building detection rules in Azure Sentinel.
Wonderful, thank you, Jan. Second question, this one is from Zoran. Can you give some pricing information? Yes, Jan, could you please open the calculator on the internet? In general, there are two models for pricing of Azure Sentinel. First model is capacity reservation, where you buy a fixed amount of data storage. The second model is pay-as-you-go. Pay-as-you-go model is meant for smaller companies, also companies size as NIL, but capacity reservation is meant for bigger companies because the minimum amount of capacity you can reserve is 100 gigabytes of ingested data per day. It's a lot of data, but to get a quick sense of how much it could cost, Microsoft offers also a calculator where you can input just I think it's how much data you want to ingest and what is the retention period, and then it will give you a price. You also, of course, have to select the region where you are located, and that's all. And then you get a price. But yeah, that's it. We are in West Europe, and let's say, I don't know, 10 giga. And by default, data retention is 3 months, and that would be $1,600 per month. But there are also extra costs. For example, if you want a longer retention period, you have to pay extra. Also, if you want to bring your machine learning algorithms, also automatization is paid extra, but this is a good motivation, because if you optimize automatization scripts, you can pay less, because each block, each integration with the tool in an automatization script costs a specific amount of money. Not all tools have the same. Here we see enterprise connector and so on. They are not priced the same, but if you have a very goodly optimized script, you can pay less for automatization processes. If you have some other questions about pricing, please contact us on the email. The next question is, are there any connectors for IBM Informix database? Jan, would you like to answer this one?
Okay, I'm not really sure, but I would say from my mind that it is possible to simply use the syslog connector. So Azure Sentinel can ingest practically anything, and if it is possible to forward from this particular database events via syslog collector or any other kind of protocol, it can be, of course, then forwarded into the Azure Sentinel.
Okay, thank you, Jan, for the answer. Do we have any other questions?
No, I don't think so.
No, that's all. Thank you for listening to us. I hope it was informative and that you enjoyed our presentation. And we hope to see you again very soon. Thank you.
Thank you. Bye-bye.